as you all know, and Joy very eloquently put it, we are on a path towards a very serious climate crisis. Probably a type of runaway and exponential phenomena going to come at us from multiple directions. And there's many studies that consistently every year, global risk studies, list extreme weather as the top hazard for humanity and the most likely source of suffering, human suffering. Most likely and the most impactful. So, those are the two variables: how likely these existential risks or grand risks are, and what kind of an impact, how nasty will they be? And always extreme weather is at the intersection of these two. Now, humanity right now has very little answers to that other than say, well, we need to adaptation, preparation, find shelter, get covered, tie things down when the hurricane comes, things like that, which is basically what humanity has been doing for the last few millennia. But some people say, well, there's a lot of people working on solutions to climate change, which is true, maybe not nearly as many and not certainly not as fast as we all need, but these initiatives focus on basically two types of things. One is reducing CO2 emissions, okay, fantastic, or capturing CO2 from the atmosphere. That's great. They'll reduce eventually the greenhouse gas concentration in the atmosphere and allow the climate to get stabilized. And then other folks are looking at ways to cool the planet in the meantime, basically, scatter aerosols or whatever it is. But none of those solutions do anything to stop nasty weather, the extreme weather events that are coming at us. The International Organization for Migrations has already calculated an average of 20 million climate migrants per year. And in the next 20 years, that's expected to rise to between 300 million and 1 billion. So what could we do? And that's where Aubrey and I started working together. It's a brilliant idea that Aubrey had in 2018, because there were a few scientific breakthroughs that year that called Aubrey's attention. First, quantum leap in our ability to forecast the behavior of chaotic systems, like really a significant leap. So that was one piece. Almost simultaneously, Aeolus, one of the most advanced Earth observation satellites, went online, and that kind of signaled the advent of an era of big data, Earth observation big data, and real-time, almost real-time big data. So that was a big piece. And then, there was also advances on new materials that allow you to change the albedo of surfaces very quickly, electrochromic bistable materials. And Aubrey thought, what if, we could predict weather with enough accuracy and far in advance enough, and with all that data intervene, say, have like a square mile or we would need to figure out the size of this of Earth's surface cover with these materials, and then make an intervention that, using a butterfly effect, will trigger a perturbation of the weather that would be positive. And that was kind of the beginning of the idea. It has been evolving as we've worked on it. So what we did is we rallied all the best scientists in these areas of knowledge. There's another piece, of course, which is we need a huge computing power. But we assume that that's going to happen, and there's a couple of other sections that are working on that. So we brought together experts in extreme weather, including NOAA Severe Weather Laboratory. We brought together the authors of these amazing papers on chaos prediction, and for a full day workshop in order to present this idea and break it. And what we got from this workshop was a validation that yes, of course, this makes sense. It could be done, but we need to improve our ability to forecast weather a lot far in advance than we have right now and with a lot more accuracy. So we're talking about revolutionary weather forecasting methodologies. And since then, this same group has produced several papers where they took basically the 2018 chaos prediction paper, multiplied by 8 our ability to predict the behavior of chaotic systems. They've doubled that, and then they've done something else. They combined those purely numerical methodologies with physical-based forecasting. So we're talking about hybridizing numerical AI, just purely theoretical prediction of weather of any chaotic system with the real weather. And they found that that improves both. So the result you get is more powerful than either. So that's where we are today. We are in the process of deepening our knowledge of how chaos could be turned from a foe to a friend. So that's the key. Then the other element is what type of intervention could we do and how big should it be? And there is a lot to be discussed. And that remains one of the big also questions that arise from this workshop. Obviously, extreme weather is far too powerful. A lot of its manifestations is just far too powerful once it's formed for us to think of many ways we could reverse extreme weather. But if we go far enough back in time, then it becomes possible. And the original idea of using electrochromic bistable materials has, well, it's open now to other possibilities. We've been playing with the idea of using existing and forthcoming wind farms, which could be, stopped or activated, and that would produce predictable perturbation. And we are open as well to other methodologies that could be done. So we've been referring to this as climate acupuncture in a way, because we're trying to use a small perturbation. And it's pretty different from geoengineering projects in the sense that it's kind of a minimum viable intervention, is localized and it's instantaneous, and it doesn't have long-lasting effects, so to speak, other than the ripple that you sent into the weather system. So that's kind of I just wanted to very informally discuss it like that and just set it up for conversation from here on, unless you, Aubrey, want to add any other piece.
Yeah, that was great, Manuel. Thank you so much. I think perhaps I want to elaborate a little bit on the chaos prediction component. So, of course, the nature of chaotic systems is that their state, changes exponentially. It becomes exponentially less and less predictable. So we know for a very clear fact that there is a limit to how far in advance we can predict global weather patterns. And most people think that the limit is about 2 weeks. So we are not proposing to try to get beyond that 2 weeks. But the difference between like 10 days and 12 days is absolutely enormous in terms of the magnitude of the butterfly effect. So essentially, if there's a hurricane that's going to happen on day 10, or let's say day 14, right? Then by day 10, by day 4 even, you are out of human manipulability. It's going to happen. And it's the location and the trajectory of that hurricane is also, pretty much no way we're going to be able to change it. But if you go back even a couple of days and you know what's going to happen with reasonable accuracy, then you've got a chance. So I think the thing I really wanted to elaborate on is what Manuel said about this work that improved our ability to predict the behavior of chaotic systems by a factor of 8. Because not many people know much about chaos theory. To be honest, I don't know very much about it. So the way one does this work is not by working with real world data. of chaotic systems. One works with a purely formal mathematical function that behaves in a chaotic manner. And the way one figures out the predictability is by taking an initial state that's randomly chosen, and then taking essentially perturbations of that state by a defined amount that essentially corresponds to the real world precision of observation that one can make. And then one starts the simulation, one just evolves the function in silico, and one determines what happens at the end of it, and one predicts what's going to happen based on the initial state. So the work that was done that made this enormous advance involved using state-of-the-art machine learning on this, essentially identifying very subtle patterns in the initial state and identifying ones that are actually important for predicting how the thing is going to be quite a long time in the future. And yes, as I say, the magnitude of the improvement that was made relative to every other prior work on predicting the behavior of this particular formal chaotic system was completely astronomical. And that was what led me to suspect that it might be good enough, or at least close to good enough, to allow us to predict the weather far enough in advance that human scale manipulations could have predictable effects on global weather patterns, 12-ish days in the future. Of course, what manipulations you would want to make depends on things like, you the prediction based on what. No intervention. You find out that a hurricane is going to hit Houston. You try a bunch of perturbations that you think you can do, and you see which one has the best improvement on that in terms of driving the trajectory or whatever. It's not only about hurricanes, of course. It's about heat waves, whatever. So that's all I really wanted to add to what Manuel said.
Thank you, Aubrey. Go ahead, Walt.
So the hurricane's heading for Houston, and you divert it a little bit, and it hits, I don't know, Alabama. Who picks up the tab?
So the reason why this, the only way this could ever be done is as a global, cohesive, single decision. You can't have two different organizations trying to make manipulations to achieve different effects, because they'll just kill each other out and you'll get some random result. Now, therefore, what this means, of course, is that, yes, one absolutely needs to determine how to make this disruption. Of course, we don't yet know how much disruption we're going to be able to make with this kind of technology. It might be that we can move a hurricane from Houston to not make landfall, and that would be rather nice. And that remains to be discussed. That remains to be determined. But absolutely, if one is in a situation being able to make a perturbation of, 100 kilometers or less, then absolutely, these are the decisions that would have to be made, and they would have to be made on a global way.
Yeah, thank you, Aubrey. Yeah, I mean, that's, I think, a common question for all of the geoengineering, weather intervention, and for many other exponential technologies that are coming at us. We need to learn how to attach governance to that. But as Aubrey mentioned, this one has the peculiarity that we either agree on what we're going to do or it doesn't work. So that may, make it a little bit easier than without their manipulations. Well, great question, Walt.
I guess the other people wanting the storm to go somewhere else and them having the ability to actually do these, because even small perturbations relatively, like they're major, like nation state level operations that are some massive deployment of a mile square thing out in the Gulf of Mexico to create perturbations for storms to Houston, right? Like these are the ability to actually, the desire to send it a certain direction and the ability to do it seem to couple. But
right, but just to put it in context, let's talk about a hurricane. Let's assume is the average intensity, which is category 2. If it's a category 2 hurricane that's already formed, the heat energy that it releases is at least 50 terawatts. So that's like a 10 megaton nuclear bomb detonating every 20 minutes. So there's no human way to do anything. I mean, it would be like sending, I don't know, a grain of rice to a charging bull, anything that we all did. So that's kind of one of the struggles, I think, of talking about weather and climate for humans is that it's all exponential functions. So once you are positioned, in a moment where the nasty weather has gained sufficient size, forget about it. And that's why the chaos can become our ally, because we can go back, down that exponential function to a place where we had the lever, which everybody knows as the butterfly effect. Probably this may take a little bit bigger than a butterfly. But that's the idea. So it's, in that sense, is peculiar and somewhat different from all those other more like Donald Trump style modifications of hurricanes that we've been hearing about.
So please tell me, you mentioned wind farms, turning them on and off, as allowing the wind to go as it would, or extracting energy from it, but with windmills turning. What other things are you thinking of like that?
We're very open. We're listening to possibilities. I mean, the first one, and we're going to be working in silico first. So as we do more experimentation in silico and figure out, the size of the intervention and the type of intervention, they'll probably go backwards and try and find, how could we achieve that? But the initial premise is something that will change basically the amount of updraft in a certain area. That can be done with changing albedo and or manipulating wind farms. Recently having a conversation with actually one of the other panelists, Creon, who's talking about satellites and space exploration and so forth. Talking to him, he's very interested in regenerative agriculture. And actually, my day job is I teach regenerative economics at UC Berkeley, and we started discussing the possibility of using agricultural sprinklers and things. I mean, wow. I'm sure this is bound to be explored, and we'll find that maybe there's several things that can be done.
Yes. And so for for any of these things, for hurricanes, it's likely that they would be the best place to put them would be somewhere in the middle of the Atlantic. That's where things start, and there might be places out there where there are, you put a floating wind farm. And by the way, the technology of floating wind farms is getting really good. There's one installed off of Portugal right now. And they're learning how to do this, without having to put the pole all the way down to the bottom of the ocean, having it established on essentially an oil rig kind of thing that's floating. So that technology is coming right along.
Yeah, honestly, yeah. I think actually what's going to happen is this is going to be much more global than that. In other words, we're going far enough back in time that it's not going to matter where you have your thing at all. It could be absolutely anywhere in the world. And in particular, when we're looking at this wind farm possibility, we have the option to have it extremely distributed, to have every wind farm in the world actually online and able to be manipulated in this way. The manipulation is quite an interesting one because a wind turbine that is rotating and absorbing energy from the wind exhibits obviously wind resistance, and the intervention would be simply to turn individual wind turbines off and stop them from rotating, which causes them to impose a fractionally greater amount of wind resistance. But of course, even though it's a very small difference, it's a difference that you can predict, based on empirical data, of course. So you can have a very good idea of what difference you're going to make that you can feed into the machine learning system for prediction purpose. And the fact that there's so many wind farms in existence already kind of leads me to believe that this is actually a very promising approach.
Right, and they're in the right places in that they're in the places where the wind is high velocity near the ground, and so that's going to have some effect. And so exactly right. The stationary windmill will have less resistance than the one that's in power.
I would actually have slightly more.
No.
Because okay,
Yeah.
okay.
Because you feather the blades so that they're just edge on, so they do essentially nothing to the wind. Whereas when it's rotating, yeah.
I haven't thought of feathering the blades. Yeah, fair enough.
Yeah.
Joy, you have your hand up.
Joy, yeah.
And there's a plane going right overhead. I am immediately thinking of this in terms of microclimate, like these sorts of manipulations. One interesting thing is there may be opportunities to purposefully cooperate these things. So for example, somebody's doing a big desert restoration project. Somebody else needs to get rid of a hurricane. Can we make the rain come to where we want it to jumpstart the desert restoration project? But also it occurs to me that one of the things to look into with this modeling methodology is it possible to find points on the Earth's surface where if you did things like you change the albedo or you change the amount of evapotranspiration or something, it has a consistent follow-on effect to decrease the extremity of weather, because that might mean that there are places to do land restoration projects. I mean, you're trying to change the amount of updraft in an area, and one of the things that changes the amount of updraft is if you take land that has desertified and you restore it to grassland or savanna, now it's got, or forest, now it's got evapotranspiration happening. The soil surface temperature is much lower. It's changing a whole bunch of these dynamics. So it's got me wondering, is there a way to prioritize restoration projects in order to give you guys like a baseline system that's less problematic in the first place, where your interventions will work better?
That's a really good question. Obviously, what we're trying to do is synergistic with all other efforts to stop the climate crisis. Indeed. And what we hope for is that, of course, I think the focus and the immediate necessities to avert those big, nasty, extreme weather events that cause much damage. Here I am speaking to you from the foothills of California, where there was huge devastation last year and the previous year, and this year is already going in. Pretty soon I'll be having my suitcase packed next to my door for the next few months. And so that's the priority. But indeed, we hope for synergistic, that a lot of what we do, like any other moonshot, will probably uncover a lot of good stuff for a lot of other folks. And we're hoping, weather and climate are changing their own definition as we move forward. The climate variability means that, climate normals, which are used to calculate climate, are getting shorter and shorter. So really is weather becoming more of a thing almost than climate. It'll be more of a worry. So, and we believe it's a little bit of the elephant in the room in the climate conversations. So by putting a focus there, and getting better technologies for prediction and giving examples of how interventions can ameliorate extreme weather, I think we can signal the way of scaling these modifications to more beneficial, stable weather patterns and climate in some areas. Cyrus.
Yeah, I just sent you a file, the screenshot for the presentation I put together with IBM Watson in 2017. We're working on the extreme weather events. How can we use AI to understand the extreme weather events and have policymakers to act upon it? So the idea was to have a platform using Watson capabilities to do a full data fusion, from satellite images to a full literature review on steroid, conducted by the NLP, to be able to understand where can policymaker act upon. That's the part, the human-based manipulation that Aubrey is referring to. And so the project hasn't seen it didn't come to existence, but it's still extremely relevant. So this type of project could be brought forward, hopefully, soon, and you have more access to data, more computing power, more AI capabilities. There's no reason why we shouldn't use these type of projects.
This is brilliant, Cyrus. Thank you so much for sharing this. Actually, I've reached out to IBM Watson not that long ago. Haven't heard back, but this is definitely on our radar. They're also, for what I hear, IBM has very interesting projects for surface Earth data, Earth observation data, in India and other places. So I'd love to know more.
Well,
about
the
what,
weather company, they have tons of IoT data that they are able to leverage. So that's very important too.
Are you
Happy
still
to take this conversation
contact
offline
with
if you
them,
want.
Cyrus?
I'd love to continue the conversation, yes, and know more about this, because it's one of the, it's on our radar, but it's not so easy sometimes to connect with this type of organizations, connecting with the right person. So I'd love to know more and see if there's some synergistic work. Yeah, it's surprising how, I think one of the great values that we may bring is, I think we've brought up some of that already, is just aggregating the efforts of many people. There is a lot going on, and we're talking about here, and part of, the kind of the brilliance of this idea is combining, and that's also something that Aubrey knows a lot about, is combining emerging exponential technologies in ways that are not being done, and that kind of amplifies them all. So it's brilliant, Cyrus. Thank you.
As far
Sorry,
as I can see, Cyrus, it's just a single page summary,
Oh, yeah,
right?
no, I can send you more. Yes, because some of it is confidential information, and I'm not very comfortable sharing it with a group, but I can share more with you individually.
All right. Thank you.
Yeah.
Fascinating.
A couple of things come to mind. It's interesting. One is, I know you mentioned Houston, and obviously they're getting, more and will more and more get slammed with these storms. And I know one thing that they're doing in Houston now is restoration of the coastal wetlands to mitigate storm damage. And I know one of the main coastal defense against storm surges and tidal waves and these kind of things are coastal coral reefs. And there's a development of these kind of seeding reefs to create defensive barriers to take the oomph out of storm surges and out of storms. So I wonder what a quick deployable reef looks like in terms of, let's toss a reef in front of the storm to suck its energy out. Because I know that coastal reefs are the first line of defense, or maybe a first line of defense against coastal storm damage, and why Houston, they kind of ripped out a lot of their coastal wetlands and put in these big concrete water, aqueducts and this kind of system. And then I realized, those wetlands were doing some things. They were absorbing a lot of energy, and they were absorbing a lot of flooding and these kind of things. So restoration of coastal ways in that way. And I wonder what a quick deployed reef looks like. There's also a question, which is, you mentioned that the perturbations are very small, so the impacts are very small. But the idea of the butterfly effect is that the changes are actually quite large, right? Like you're preventing 20 kiloton nuclear bomb going off every 20 minutes for some period of time. So the energy from the storm is coming from the ocean in terms of that heat energy that it's absorbing and this kind of stuff. So if you perturb and stop the Category 2 hurricane from coming into existence, that energy is still there. It's in the ocean. What are the implications of that? Like, what are the implications of the storm is doing something, it's extracting energy.
Right. Smaller localized storms and more of them can let that energy out.
Well, yeah, I mean, all those terabytes are flowing, through the atmosphere at any given time. It's just differential between potential and kinetic energy. This storm just accumulates all the energy and unleashes it very, very strongly. But your conversation, James, I think your comments gives me an opportunity to make a very good point. Is that, I mean, what you were talking about, just deploying the instant coral reef, which is kind of interesting proposition, is like what the sailors used to do, dumping oil over the sides of the ship or whatever, I don't know if it's myth or reality, but all those things are part of, what is called adaptation for extreme weather. And that's a lot of people are working on that. How can we protect ourselves from the actual storm? And what we're talking about is the storm not forming. And that's important to make the distinction. That's kind of what nobody's working on, basically. It's like, how could we reduce the size of the storm, or send it somewhere else, but work really at the beginning of it, so we don't have to deal with those orders of magnitude of energy that we cannot handle. And that energy is in the earth. It's a system that is in balance, and the moment it gets off balance, then the energy manifests itself in ways you don't want, and very strongly. Not only that, but something that is happening with extreme weather that few people in the world are studying is that different manifestations of extreme weather and weather variability are coming together in a systemic way and amplifying each other. For instance, there is an obscure paper from UC Berkeley that says that lighting strikes are going to double in the next 10 years. Okay, who cares? Now, pair that with mega drought. What's the effect of lightning strikes together with a mega drought can be complete devastation. So there is a mutually synergistic and systemic compound to the new kind of weather that we're going to see. So much so that we're trying to coin a new term to talk about it. Right now, we're talking about super anthropogenic weather to describe it, because things are going to pile up on top of each other. So it's likely that when places like Houston get hit by hurricanes, they're probably being hit by other things before, whether it's drought that is killing those wetlands, or it's heat waves, or all kinds of things. And that is going to interact with human systems too. It's going to displace people. It's going to change the behaviors of people in ways that's going to affect weather too. So the feedback loops are very complex, and nobody's really studying that.
Yeah, one thing that came
Just
to mind
wanted to make that plug.
Describing was the desertification of the Sinai area. That apparently, like to the degree that it totally shifted the entire wind directions in the whole like Sinai area, with the wind no longer coming in off the Gulf there, and instead blowing from inland out onto the water. That then got this flywheel going of continued drying, continued desertification. That totally shifted all the weather patterns in that whole area. Just in terms of the surface temperature and this kind of thing. So I wonder, there's like spot treatments, and then there's what she was kind of mentioning, installing or doing regenerative ecological work for permanent installations that prevent uncounted future hurricanes, kind of that kind of thing, as opposed to there's a hurricane, we see it coming, we're going to go and put this material here right now, because 10 days from now we're going to finish storm. It's kind of broader, like region-wide weather pattern changes that can prevent mini hurricanes indefinitely, kind of thing.
I think Oberheim, that's very, very well put, James. And I think the reason why we're doing this to begin with is we want to restore the health and the balance of living systems, and that is going to take a lot more than just averting some extreme weather. In our advisory board, we have Bill Liao. He is the founder of WeForest, and he's someone who pledged 10 years ago never to take a plane before he planted 100 million trees, which he did this year. So we are in connection with those folks, and we want to make sure that they understand what we're doing, and we understand what they're doing, and we all work hand in hand towards that future of thriving living systems and balanced living systems. Yeah, go ahead.
Okay, I see Joy wants to speak as well, but quickly.
Sorry, Joy.
As it stands today, there's absolutely no accountability. So if you or your country creates a situation that changes the weather in my space, too bad. Likewise, if you shift that hurricane and maybe you break it up and it happens to kill my kid, I'm not too happy about that. But
Right.
yet, who's going to pay for it? Has an enormous legal and international. So you shift it from Houston down to Mexico. How do you suppose Mexico's going to feel about that? And it's, there's no accountability now, and there's no talk of accountability in the future. It's just shifted away from Houston, so it goes to Galveston or whatever. It's like, well, Galveston's not going to be too happy about that. Who's going to pick up that tab? And since it's a conscious act, it's liable at a much higher level than something that's purely accidental, and so on and so on and so on. And so, we know, for instance, that that military stuff is a huge contributor to all kinds of climate change factors. But we see nothing, we never hear that talked about as it's something to fix, and so on. I'll shut up now.
Yeah, I agree with you. It's lack of accountability and also lack of traceability. Like, we live in very complex intertwined systems already, and that's a big problem. Also, you see that conversation is what is hampering a lot of the work around climate also, because, folks are saying, hey, you guys, you rich guys, you are the ones that have caused this. You ought to do this. And also the countries that now are developing, they say, well, you guys developed and emitted your greenhouse gas emissions. We want to do the same thing that you did. Why should we not grow? I think we're entering a new era of challenges in the field of governance in many fields, not only this one. And the type of conversation that you're proposing is going to be more and more common and necessary and important. And Joy, you had a question. And by the way, let's make it all a dialogue. No, it's not like Q&A. So if Walt says something and you, Ted, has something to say, let's all unmute and go with it, because I think the group is big enough and small enough to do it.
Okay, cool. So a couple of things. There is a friend of mine who founded and runs the Soil Carbon Coalition, did a back of the envelope calculation about 20 years ago. Now, this is a bogus number. Okay, this is totally bogus, but it gives you some scale ideas. We know that there are people who are growing an inch of topsoil a year using regenerative grazing. There's a particular way to do that. Now, that's an ideal case, okay? But Graham Hand in Australia was reporting, these are probably not very good numbers because measuring soil carbon is quite difficult, but he was reporting sequestering 10 metric tons per hectare per year on his place, that's ideal growing conditions. So my friend Peter did a back of the envelope calculation of, let's take the land that humans have turned to desert, and let's take the world's grasslands, and let's just pretend that they were actually that productive and we could pull that much carbon out of the air, which is a completely bogus number because there are a lot of places that are that biologically productive. Even in ideal conditions, it's too cold, the growing season is too short, yada, yada. But he calculated it would be possible to pull all of the anthropogenic carbon back out of the atmosphere in, if I remember correctly, it was around 20 years. So that's a bogus number, but that does suggest that if we did things on a widespread basis as quickly as possible, we could actually have a quite large effect so that people like Manuel would have less extreme weather to mitigate much more quickly than we think. And the Water for Climate people in Europe, in Slovakia, they figured out that at least in Europe, 30% of local rainfall is the result of evapotranspiration locally, mostly through trees, wetlands, and grasslands. The wetlands evapotranspirate the most. So that water in the local water cycle evaporates and turns back into local rain, okay? So they were, I'm sorry, I got the number wrong. It's 70% in that area of the world, right? So again, by revegetating things, we have the possibility of having a lot more cloud formation, drastically changing the local rainfall. that's going to cool the surface temperature, which is a contributor to warming. And of course, between a third and a quarter of the excess carbon in the atmosphere actually came from soils fairly recently. So reversing this, like, we don't need to necessarily, if we can get globally coordinated,
Right.
we don't need to decades, hundreds of years of what Manuel and Aubrey are talking about. We need to do it as a stopgap measure until we can calm things down, and then it will be less necessary. We're always going to have some extreme weather.
Right. Joy, this is all very exciting and true. And we brought to our workshop in that we had the author of the geoengineering paper that has been the most cited and downloaded and whatnot, Safa Motshare, and he did a study of what large-scale installations of solar and wind farms in the Sahara would do, and basically would green the Sahara in a short term. And there's papers like this. There's an abundance of papers that, in back of the envelope calculations like your friends, and projects that signal the way, ways that we can reverse climate change. But there is not. But see, we're talking about climate. If you talk about weather, then there's nothing, and you get everyone's skepticism. And this is important to I want to mention this because this is what makes our project interesting and different and challenging. Is there is almost no evidence that humans can do interventions that would change weather more than statistically. And that's where we're going.
Right. So, but the Slovakian data does very clearly show that human interventions on a fairly modest scale can change local weather. That's not extreme events, that's average, as you're talking about.
Mm-hmm.
Okay, but the fact that they can do that is actually pretty good evidence that what you're doing has a very high likelihood of being able to succeed. And this is very exciting news.
I know.
So the question, to ground it back into weather, you say kind of the blocker, or the main blocker right now, or what your main focus is right now, is prediction, right? Like improving weather prediction more and more and more. And there was a US government, what did they call it? MAG something. It was a competition for proposals for MagQuest, I believe. Competition for proposals for monitoring, ways to get as close to live data monitoring on the electromagnetic field of the Earth as you can get. And they had opened up a competition for proposals for how to go about doing this. And there's an interesting question of, there's a combination of, but I have heard a proposal for it that was never sent in. But what it was is the idea of especially in the context of foresight, there's a couple ideas that intersect here for me, which is if you've heard of this platform Numerai. Numerai is a hedge fund that is pretty much publishes all their data publicly, so their users can build financial prediction models on top of their data, right? Generally, the hedge fund's main job is to keep things secret so they can make money and other people can't. What they've done instead is take all the financial data they have, obfuscate the actual like signals, like what the data is. They've obfuscated that, but they've released the features of the data, like the contours of the data, and then other people can build, users on the Numerai platform can build prediction models, and then they compete with these prediction models and they stake Numerai tokens. It's a cryptocurrency kind of play where they stake Numerai tokens on their prediction model. If it works, they make money. If it doesn't, then they get their stake slashed. And then, so the Numerai hedge fund itself is using, pretty much uses a machine learning model over top of this human competition in prediction to take a stake weighted average of all the stakes that are being staked on these different prediction models. And the founder of Numerai actually just talked to Foresight about this. So there's a Foresight video on it. What he explained was that you can get, like, Allison asked, are there other ways that these prediction kind of market aggregations would be useful? Are there other realms of data And he said, well, honestly, not really, because the thing about financial data is that you don't get much of an edge. You might make a model 51.5% accurate instead of 51% accurate. But in quantitative finance, that's a huge deal, because the margins, they're working with such vast sums and the margins are so tight that getting that tiny, tiny edge, even if it's a 0.5% or something like that, is a huge deal. And it strikes me that weather data and the kind of chaotic systems that you're working with might be a realm in which a model that is 51.5% accurate as opposed to 51% accurate might be a huge deal for weather prediction. And my MagQuest proposal was a hardware, cryptocurrency mining hardware, that the mining process was sensor reading weather and geomagnetic data to incentivize the deployment of this hardware network all around the world to start reading data. So a network of folks that miners that are being paid, rewarded for deploying weather stations effectively. And every reading that your weather station delivers, it gets rewarded in some amount of currency, or some amount, weather token, whatever you want to call it, that then creates a sort of a it's a blockchain that then when you talk about having a public ledger of weather data, which is sort of where we're going. You're talking about the era of big data, weather data. You could take that, put it in a public ledger that's then being fed by a decentralized and kind of like self-rewarded or like self-rewarding network of folks that are mining the weather to make money and to feed the data beast to get more and more data. That was my idea for this MagQuest thing. It strikes me as potentially interesting. And then an open human competition for predicting weather. Publish all that big data, put it online on this public ledger. Anyone can build predictive models over it. Anyone can run their chaos models over it and do math, and then let people bet on weather prediction models in a prediction market kind of way. And then you have this another layer of signal where you have machine learning crunching the actual weather data. And then you have humans betting on top of the prediction models as to where the storm is going to hit. And then you have machine learning crunching the human betting markets as an additional layer of potential signal. And it works for Numerai. They're making a lot of money on crunching, machine learning, crunching data over the stake weighted human prediction betting. And they're getting a tiny edge, and that's all they really need because they're a quantitative hedge fund. I wonder if something similar could be useful here in terms of a open public prediction market betting platform for weather patterns globally, and then machine learning on top of that to create a meta model that's informed. And then you end up with this kind of open competition for weather predictors, and you end up with super predictors, and you end up with people making money on weather predictions. And just thoughts.
Amazing. You found a way also to turn Las Vegas from an environmental villain to environmental hero, potentially.
Right. I think there's always a horseshoe effect there, like Nestle could become the hero of humanity for its water if it decided one day to turn around its use of water and its kind of managing of water resources. Or like IKEA uses like 1% of the world's lumber, something like this. So when they shave off a gram on that dresser that they sell 10 million of per day, they shave off a grave of wood. That's a huge change, like a really meaningful change in the amount of lumber being used by the planet, sort of, because they're using so much. So there's an interesting horseshoe effect of like the biggest environmental damagers, I suppose, seem like the ones that are most in positions to become environmental heroes and write themselves into the history books in that way if they so choose, I think.
So I have a quick question for the group also. So how can we foster and leverage these like global ideas around? 'Cause, I mean, they stay very niche and very, they stay here at Berkeley, or and they're not really spread. How can we spread the word around? So X Prize is trying to spread the word by having these kind of global competitions. But I feel there is, now is the time to leverage these ideas. And have you looked into? So I put the Metaculus angle into it because they're trying to leverage your collective intelligence. But have you looked at projects where we will leverage collective intelligence to bring this type of technology solutions to climate change?
We are looking right now at putting a challenge to an organization. Let me get my together here, but basically we're looking at creating a challenge within the AI community now as a nonprofit that would rally 50 AI experts for 2 months to work on the premise that we want them to work on is demonstrate that whatever human feasible local intervention wherever in the world, whenever in the world, could at least in a model show a beneficial modification of weather. And that's the kind of it's not exactly collective wisdom, but it's kind of a project that we are considering right now to undertake. And if you give me a minute, I'll find the name of the organization and paste it on the.
If you want me to present this to X Prize, because they're looking for ideas. So right now they have this massive prize with Musk, $100 million for carbon removal, but they are interested in other ideas. So, one way, and they have a global reach. So if you want to have more impact, happy to put you in touch with X Prize there on this.
That'd be great. That'd be great because definitely I believe that there's so many moving parts to this that we need a lot of collective wisdom. And what you were saying initially, that there's all this disparate knowledge, that's exactly what we're trying to do. Just bring together all the elements so that we start making progress, in a synergistic way. Here I'm pasting on the chat. The organization is called Andina. I don't know if you know it or have any reference, but they do. It's a nonprofit, and they take on projects as challenges, and they put 50 AI experts per project. So we're looking at trying this out. Just take that step, because one of the consistent feedback that we've received we talked to a number of organizations, notable tech companies, you name it, and they say, that's awesome, but show us that you can de-risk the idea a little bit. Show us that it's, minimum viable demonstration. So that's what we want to take to Omdina, so then we can come back and apply and help us raise money and move forward.
And are you linking up with UN Environment, for instance? Because they're looking at the data and AI more and more, and they have a good team there, and I'm happy to put you also in touch there.
Linking up with whom? Sorry?
UNEP, UN Environment.
No, we haven't yet, no.
They're obviously looking at this data and AI angle to tackle climate action.
Maybe the elephant in the room that hasn't been discussed yet is wastefulness on a massive scale that applies to everybody here and everybody in the whole world. Everybody needs to have their new car. Everybody has to have their new clothes. Everybody has to go on their lavish vacations, on and on and on. Try to get people recycling. Try to get people. It's very hard. Birth control. We have some of the places that are most in need are the ones that are having the most kids, and so on and so on. It's those things. We haven't had good success in those areas. I don't know what to do.
Yeah, thank you for bringing it to a meta question. That's my, I kind of delve into that with my circular economy classes that I teach at UC Berkeley. And I teach to an executive level. So I get lawmakers, sometimes I get a minister or two, I get CEOs, and I try to break their head open, asking questions like the one you just asked, and stay with the questions, because really we need to stay with those questions and keep going and asking the right questions. And I think those are the right questions to ask. I don't know if we have answers to them, but we need to keep asking them and having them at the forefront. I couldn't agree more.
You have a lot of countries that are actually encouraging their people to have more babies. So, that's going to help,
Right.
I think it will, unironically.
Joy?
I had an idea which you have probably already thought of, but if you can find, for small scale deployment tests, if you can find a place where there is a consistently repeating butterfly effect for a local area, there is a valley where they tend to have like mini windstorms or something, and you can get upstream on that and mitigate in a tiny little area in order to do that. If you could find a consistent repeating pattern there, then you could start testing the interventions on a very small local scale and start to get an idea of how much intervention do we need to do to have this much effect downstream, because it's predictable, right?
Well, that's kind of the beginning of the inquiry, is how do we pick the location, the time scale, and like they are all variables right now. So we need to, part of the how we need to be smart is in choosing exactly what you just said.
Right.
Places and times of years, and also what type of weather we're talking about. Is it precipitation, is it heat, what is it? Yeah.
So I think
if you haven't already talked to Tom Chi, because he's a genius at exactly that kind of thing.
So one of those places that might be good for a test is Tornado Alley in Kansas, where there's small effects are determining where tornadoes occur and when. That might be a great place to test.
Thank you. We had 3 experts in tornadoes in our workshop. They all live in different places there in tornado country, and they are professors of meteorology with a focus on tornadoes. So that was actually a focus of the workshop. And a lot of the feedback we have is actually from tornado experts.
Yeah, you might be able to do something like go to the Toulouse Valley, where they have extreme dust. That's in eastern Washington state, I believe. They have extreme winds and dust devils. So it's not a tornado, but it's happening a lot more often, a lot more predictably at a much smaller scale. But if you can find someplace that is spawning dust devils every time there's wind from a certain direction at a certain speed, then you can start testing mitigation things there at a micro scale and find out, what do we need to do if we increase the albedo, if we decrease the albedo, if we change the heat, if we angle winds differently, if we put up a little mini wind farm, what happens?
That's great feedback, and that's the kind of thinking that we need. Having said that, what we're looking right now is for in silico experimentation. So we're looking just to take past data sets of weather. We know what the weather was everywhere, right? But picking a place so we can model a modification and then compare the outcome with what the actual weather was. So that's the way we would do it at this stage. We'll be going in silico.
Yeah.
If I were you, if you can figure out a way to find a place like what I described, and put up some monitoring stations now, so that in 2 or 3 years, when you've done your in silico stuff, you will have 2 or 3 years of data where you had a very dense level of monitoring stations, then you're going to have a way better place to run experiments, because you'll already have that data, and you will have much better modeling data for that little micro thing. Just saying. Thank you. I mean, as a nonprofit organization, an ACEN organization, we're also faced with scarce resources. Both Aubrey and I have our own, full-time jobs, and we do this on the side the best we can. We've raised some money. We
work with scientists, but there's a lot of development that we need to do for us to be able to do our own experiments of the nature you're describing, hopefully soon. But for now, it has to be opportunistic, in silico, and very nimble, startup style, and moonshot style also, because we know that there might not be a lot of commercial value or tangible value of some of the things we do in the near future.
Yeah,
so I put some limitations.
An interesting angle, and we can talk offline. I can try to connect you with some of the folks, because I think that a way that there's raising a lot of money for this, especially as a nonprofit, like you said, is hard because there are no commercial values. But maybe you've noticed, but a way that a lot of people are making a lot of money these days is releasing your cryptocurrency protocol. And a way to do that's not inventing a solution for a problem that doesn't exist, like a lot of cryptocurrency protocols tend to do, is I think this open betting platform for weather prediction is really interesting, because what it does is it taps into one, you can generate a lot of funds like pretty quickly, because one, it's a cool question. It goes towards Cyrus's comment on how to actually get some eyes on this, which is, well, let anyone make a little bit of money, instead of like the challenge prizes, like the X prize are very much their pull, right? Like they're like, hey, there's $1 million at stake here, apply. So they're very much pull press. And then, or you could say, or an open prediction market platform for weather predicting models, it's taps a few things, because one, they're pretty simple to make, like technologically now. So like you could work with, especially with the Foresight folks, like just the blockchain engineers in the Foresight Intelligent Cooperation Group, that would be very happy to build something, I think, similar to this, because it would be somewhat simple. The Numerai guy, I would talk to, I'll link you with him as well, because what you're talking about is back tests. And what the Numerai guy spent his whole thing on was talking about quantitative back tests for financial data are, right, Ted, you could tap into Purple Air and these other big decentralized weather station networks, layer a prediction market on top of that, funnel X% of the funds from that prediction market, which you're just transparent about, say 10% of all the money made on the betting market goes to Viento, and Viento is using it to send people weather stations so they can start betting, send out more sensors and more data. I think that you could potentially create a way that you're not writing grants and trying to find opportunistic grant money, and you're not beholden to anyone attempting to invest commercially, by creating a market where a lot of people are making money, including you. And it gets eyes, because right now, if you're talking about let's get attention on this, you ride the hype cycle of crypto betting potential, like markets, like, there's huge hype, huge PR, huge press around it. You have these existing networks of sensors and weather data and this kind of thing. And there's an interesting piece that I think is the local information about weather patterns. The farmers in Kansas could probably tell you way more about whether there's going to be a tornado later today just by walking outside and feeling it out, right? Because there are subtle atmospheric differences that are so local, and that local information, how do you unlock that local information? I think is let anybody bet. So that farmer in Kansas can now make a little money, because they have been farming for 50 years in that valley, and they can predict the weather in that valley. And every Kansas kid has grandpa who could tell you a storm's coming to the minute later, because I know I've lived in Kansas and Missouri and like all through, and like there's local information about weather patterns that are like embedded in like just human, we don't know how it works, but it works kind of ways. So unlocking that local information, but in a way that benefits, one, the people that have the local information, and then everyone through the data aggregation, and then Viento through, I think, a betting platform that can make a lot of money. I think that there's a play there that could like decouple you from the resource constraints that these projects typically have. and simultaneously actually not just for money making, but tap that local information that otherwise is lost because farmer in Kansas is not applying for the X Prize in weather prediction modeling, right? Like it's just not a viable thing. But they might, especially if their kid says, "Hey, is there going to be a storm tomorrow?" I said, "Yeah, there is." "Hey, I just made $20. How cool." Oh yeah, something to say.
James, I think you just pitched yourself as fundraiser for Viento.
Yeah. If I may, what about simple things? I mean, this is going back to everything, but say, for instance, if everybody painted their roof white, or if everybody dyed their hair white, like Ted and I have done, would that would that cause a significant effect, or is that just a with how do you say?
Well, it's
Depends how much time you spend indoors, I would say.
Yeah, it's a micro version of, as far as I understand, the ice caps reflect a massive amount of heat from the planet because of the ice and the snow and all this, and them melting and darkening is
and most roofs are dark colored. I mean, just take a look.
Oh yeah, and the temperature differential is
in Florida.
Huge. Yeah, this taps into something that I'm interested in for these micro local interventions is, we don't have a way to coordinate stuff like this, like you were talking about, Walt, but actually local property taxes could in fact tax dark roofs, and it could be a net revenue neutral tax, so that it goes, tax on dark roofs is used to subsidize people turning their roofs reflective, right? So you could have just this local property tax measure that could have a little effect.
Or mitigate the losses of those who have waterfront real estate. Yeah, Ted?
Yes, so I've been wondering, so it's actually the UV that's important for roofs, that the UV comes down IR, and that's the part of global warming. I hope you can still hear me. What substances on the roof would reflect UV straight out? And I think metal is the main thing that reflects UV. And so maybe it doesn't actually matter the visible color of the roof, it's the UV color of the roof, whether it's a mirror or not.
Well, that's a good point. We want to first find out what's the ideal thing to do it. What color, in quotes, do you paint it to get the best effect, eh?
Yeah, we're talking about albedo. That's I think the variable that you want to look at.
Yeah, I actually did a little research on that many years ago for chicken tractors, of all things, which are portable chicken houses. You don't want the chickens overheating out on the pasture. And it turns out that metal was much worse than white for just how much heat, how hot the roof gets and how hot it gets underneath. So I can't tell you about UV reflection though. But this is great. Thank you, everybody.
I will say in the pause
thank you so much.
that we're technically past. I mean, maybe you saw the note from Allison at the top of the screen a few minutes ago, but we're taking 11:30 was our scheduled time.
Oh, okay.
There's no cutoff, so I don't want to cut momentum if you're down to keep chatting. But yeah, just to give people a graceful exit if they'd like to.
Thank you so much.
Exit.
Pleasure. My email is manuel@viento.ai. Don't hesitate to get in touch. James, thank you so much for all your contributions and for moderating. Thank you, Joy, as well. And Ted and Donnie, who joined us a little bit later and didn't participate much, but thank you for being there too. Thank you. Have a wonderful day.
Great. Thank you, Manuel.
Thank you very much. And thanks for doing this exciting project and bringing it to my attention, because I didn't know about this. What a brilliant idea. And as you say, so different from mitigating climate. So, also, there's a guy named Frank Landis, who's a futurist who has talked about, we have things like Elon Musk is like, let's go settle Mars. And Frank said, if we build on Earth the technology that will allow us to live on Mars, that is kind of by definition pretty much climate change proof places for humans to live. And it would be a lot easier and cheaper to do it here than to do it there. So another cool project that needs to happen, and there are so many.
Right,
But no,
back in the realm
world is going to-
of adaptation, kind of, which like I think that's like you're saying, like that's another huge piece of it, which is like restoring reefs, restoring coastal things, and then building infrastructure that is, you know, when you can have your funky cabin in the Santa Cruz Mountains, and you just hit the big red button and it folds up into a fireproof box. The wildfire comes through, then you hit the big red button and it opens back up. Like, because you had these, like the fires, that's a specific example, but the fires are, you know, it's somewhat normal. Like it's you know, these giant wildfires have been the norm for, as far as we could tell, many thousands of years. You know, way before industrial like society started dumping carbon in the sky. Like, you know, still forest fires are forest fires, and how this was approached by the folks that lived here, you know, then was mostly through mobile and rebuildable infrastructure. So they were building, you know, they had huts and tents and these kind of things that they were moving with the fires, right? So like, especially in the Great Plains of the United States, as far as I understand, it was like massive migration, whereas all year you followed the fires effectively, and the tribes were just moving their whole towns. And so they'd be continuing moving because the fires would go through, then all that ground would re-lush itself, like all the grass would grow from the carbon being burnt into the soil, and then they'd keep following, they'd get to the east, maybe to like the Mississippi, they'd kind of turn back around and head back the other way. So like fireproof buildings as
so it's quite amused. Yeah. And things like being able to sink your house underground or whatever.
right.
You know, or maybe you sink your house underground and you leave for the time being and come back later. But
a fun thing. Yes. I lived in an old like 1800s settler farmhouse in the Santa Cruz Mountains, and we did evacuate last year for the wildfires. And one thing, an interesting fact around that house is that underneath the house, under its foundation rather, is enough redwood planks to rebuild the house if it burns, that were put there in 40 something when they built the house. And apparently that was regular practice, right? Which was you're going to build a house, you put enough wood to rebuild it under it, then build the house on top of that, because it's gonna burn. So when it does, wow, you just pull out the extra wood, fill in with more wood, and then you pull out the extra wood and you rebuild the house with that. So in terms of like, there's a vibe of like, we got to stop this extreme weather, which certainly deserves some amount of thought. And then there is my kind of question with the claim that it's like out of balance is like, well, this weather it's for something. It's sort of the case for some reason. So I wonder what the one major feature of chaotic systems as well is that we don't, like the butterfly effect. The whole point of the butterfly effect is kind of a warning story, right? It's like, you don't know what's gonna change. So like, if you prevent that fire from going through, we've been preventing the fires from going through for many years, and we've gotten ourselves into a position where now there's all this fuel buildup. Now that we interrupted the natural fire process, so through fire suppression, that has gotten us into more issues, right?
Yeah, and there's another issue, which is we don't actually know what the natural fire regime is. So, for example, if you look at mud records in ponds in the Midwest and say the Kansas Flint Hills, at the point the Faleo Indians show up, the fire frequency goes from once every like 50 to 100 years up to once every 20 years. And then now, you know, the Western managers are, because they're not managing the grazing animals, so they avoid big buildup of grass. So they're doing, in many cases, once a year burning, which is far more than is sustainable or optimal or anything. And we don't know on the West Coast, you know, when I'm on, you know, you're in the Santa Cruz Mountains, I'm in Berkeley. And when the Paleo Indians showed up to this area had mastodons and mams and temperate zone moxen and bison and giant, right? So we don't know what was doing the ecosystem maintenance. We probably didn't have the dense understory like we do now. I mean, we don't have the grazing animals like in our national forests, right? We don't have the predators to manage them. We don't have the animals. We don't have the same species or genera for the most part that were here. I mean, there were 22 species of pronghorns in North America when the Paleo Indians showed up, right? So we have all this ecosystem maintenance where a lot of the adaptations to those missing animals are still in the plant genome, but the animals are gone. The Indians used fire as the natives used fire in Australia. And so, but that was far, far, far more frequent than had been the case before they showed up, and changed the entire ecology of Australia, changed the ecology of North America. So we don't really know what the natural state is. And the other thing is, I was friends for many years with John Pollack, who was a long-range climate forecast specialist for the National Weather Service in Valley, Nebraska. And, you know, back when people were first starting to talk about climate change, you know, John's a long-range climate forecaster, right? And he was going, well, the problem is that the normal fluctuations are so much bigger than people think. Like, for example, if you go, if you start in Omaha, Nebraska, go across the bridge east over into western Iowa and go up on that first line of bluffs, there are cacti on those bluffs. How the heck did cacti get there? You don't get cacti for 500 miles west, okay? Why is there this island of cacti going up and down the western slope of the bluffs on the Missouri River? Well, because there was a period of about 1800 years where the rainfall in the Midwest was half of what it was now. We know what that was like. That was called the Dust Bowl, right? So that's just a normal climate fluctuation, right? And all our agriculture is based on the best 100 years of weather since the Middle Ages. That's what they built industrial agriculture on. Oh, this is not going to be pretty.
Yeah, I mean that's sort of like a kind of response or like a pushback that I have to a lot of climate theories. Like we sort of like arbitrarily chose a point that's climate normal. Now let's make really big investments and do really big stuff to attempt to force the planet into a climate situation that is equal to this kind of like somewhat arbitrary point we chose to call normal. And I'm skeptical of that. And it's questioned because like you say, these perturbations are happening. So it's a little like,
we are pushing things though in directions that they have not gone before, and where the fauna and flora probably don't have good adaptations to them, because we don't have, things were not as warm as they're about to get for a long time. Carbon was not as high as it's about to get, right? And in fact, most of the time for the last 800,000 years, we were in glacials, not interglacials. So there's more adaptation to that in the plant and animal genome and their physical location than there is to the warmer conditions. We haven't had that recently. So we're basically stressing everything in ways that it's not that it's necessarily bad and wrong, but because climate does change, but we are doing it extremely fast, which nature sometimes does, but we're doing it extremely fast in a really radically different direction. So, we're in the situation of the life on Earth has basically been optimized for the racetrack for the last 800,000 years. And now we're going, oh, let's do long haul trucking. A lot of life is going to go like, oh crap, I can't do that.
Right.
And our previous experience with disrupting ecosystems says that we can do some pretty serious long-lasting damage. And we don't, humans are so time constrained, people don't think about what we're paying for now. That is, you were talking about the Sinai, right? And, you go back, you read Herodotus in 450 BC, and he's talking about North Africa. You could walk across it from one end to the other and never get out from under the shade of a tree. And it was known for its deep, rich soils and abundant springs and rivers, right? And then the Romans came and did agriculture, and they instituted a kind of land management where, as they used up the topsoil and desertified it, it was not given a chance to recover. And thousands of 1,500 years later, it's still desert, 1,500 years after the Roman Empire collapsed. And yet you can find little pockets of the original soil where trees are still growing. It's not the climate, okay? And there's stuff like that all over the place. You go to South Africa and you go to the central part of the Karoo, and it's desert now. And you read the accounts of the original settlers just a few hundred years ago, and they were going, we rode through stirrup high grass and we came over the ridge, and there were tens of thousands of springbok and this bok and that bok and quagga and elephants and giraffes and so forth, right? In what is now a desert. We did that. And you can still see on the map, there'll be places like that are named things like Springboksfontein. That means fontaine is fountain in Afrikaans, right? So these were all places that had artesian wells because there was so much water going into the ground and replenishing the groundwater that are now desert, and those wells have dried up, right? Nevada, right? You've been through Nevada, right? And you see, like 3 feet, a meter of bare ground, a desert bush, a meter of bare ground. That was bunch grass prairie in 1875. We did that. That's not naturally a desert, okay?
An interesting thing there is the revegetation that Las Vegas is causing in the valley there. Have you heard of this?
I haven't been there recently, so.
Well, it's apparently continue. I interrupted you.
So let me finish my point. The Indians showed up to the Bay Area here, and there were horses and wild asses and camels and llamas here and in much of the rest of North America. And they rendered those things extinct. And for 12,000 years, they didn't have good domestication candidates in North America. There were no riding animals. There were no good pack animals because they wiped them out. We are paying for what people before us did, and we're pretty much oblivious. We think the world just is this way, but that's not the case. And I personally, I don't want our legacy to be as those assholes who wrecked the world. I want our legacy to be, those were the people that finally solved the problems that nobody in human history had the technical know-how to do. They got it right. They were the heroes. Let's be those people.